Okay, hello everybody. This is the CUDA and Open Lab seminar on May 13, 2024. And today it's our greatest pleasure to have Sybille Krämer, who will talk about the cultural history of flattening as creative potential, which is about it's a reflection on the medial condition of digitalization, which we're all dependent on, and we all have to deal with it, I guess, in the humanities, in cultural data analytics, and in the rest of the world. And so we're very, very curious, and the stage is yours. We have, as usual, a 2-hour time slot. The guideline usually is like talk for 40 minutes, but you can totally talk for 2 hours. You can talk for 10 minutes and discuss with us for the rest. You can take questions in between or just talk and take questions afterwards. So the idea is to have fun.
Okay, I would prefer first to give my presentation. I hope it will not take longer than 1 hour around about, and then we have our discussion. That's okay?
Excellent.
Okay,
Looking forward.
I take my glasses. Wait a moment, please.
Okay. Nice.
Okay, I do not know where they are at the moment. It doesn't matter. Thank you very much for your very kind invitation. And now I want to present you something which is, so to say, the topic of my last year's research on digitality and even on media. And now I will start. I have a PowerPoint, as you see, and yes, now I will begin. A central belief of contemporary social theory is the idea that Western civilizations form digital societies. Our culture is a culture of digitality. These statements, and who would doubt it in any way, take a tacit assumption. The computer is situated in the center of digitality. Computerization and digitalization appear to be two sides of the same coin. The following considerations want to dissolve the close connection between computers and digitality. The following considerations, as I told you, want to dissolve this strong bond. Embryonic forms of the digital have already emerged under the conditions of alphanumeric literacy. The contemporary career of the digital would hardly be explainable without its connection to the alphanumeric. My argument concerning this connection is based on an anthropotechnical phenomenon. I call it the cultural technique of flattening. It's a little bit provocative concept, but that's only half the story. We are witnessing the ongoing digitalization not as something familiar, but as a disruption and radical change. If there is indeed a continuity between alphanumeric and digital literacy, what is the difference? The unparalleled novelty of actual digitization. My argument here will be that it is not progress in computer technology per se, but datification. New types of data architectures are created. You all think about big data, and operated by learning algorithms. Both continuity and disruption. This is the perspective presented in this lecture, are linked to the phenomenon of writing. My presentation proceeds in 5 questions. First, what does digital mean? Second, why is the reductive cultural technique of flattening so productive? Third, how is artificial flatness connected with digitality? I will give you some pioneering examples. Fourth, what is data? And why are computers forensic machines? And last, do chatbots understand what they produce? Let us first clarify what does digital and digitalization mean. Digital is to be understood dynamically as a process of discrete decomposition of something continuous. A fluxus, a continuum, is broken down into disjunctive elements that can be coded and more or less arbitrarily combined. The etymological origin of the Latin word digitus, finger, is instructive. Fingers are distinct from each other, but the potential of the hand is based on the functional connection between the fingers. Digitalization is a transformation in which something that can be regarded as relatively continuous and therefore analog is split into basic elements that can be coded and combined into variable structures. All writing systems, insofar as they are discrete and disjunctive, constituent early forms of the digital. This applies in particular, but not only, to our alphabetic script, as well as to the Indo-Arabic decimal position system, which we use to represent and calculate numbers. The alphabet and the decimal position system embody prototypes of the digital. The affinity between writing and digitality is crucial. But why do we emphasize the written nature of the digital? I want to answer by going back to the alphabet and the numerical position system itself. Although oral speech includes some breaks when taking a breath, there is no equivalent in the flow of speech for the spaces, the gaps and paragraphs in alphabetic writing. Alphabets divide the acoustic flow of speech into meaningless but visible disjunctive units. Letter writing transforms fluid oral speech into a thing-like entity called the language that can be observed, transmitted, and archived. Speaking of language is a kind of object that we possess and use. And this is a consequence of its spatializing transposition. Originally, communication was a mixture of verbality, facial expressions, gestures, prosody, and deixis. It was not until the writing of letters that the verbal level was separated from the other communicative components and modeled as an independent autonomous system. Jacques Derrida was therefore quite right when he claimed that writing precedes language. The linguistic phoneme is the descendant of the grapheme. But understanding the potential of digitization by alphabetic writing already means realizing why an alphabet is more than transcribing spoken language. It creates an efficient sorting register that remains neutral about the content sorted. Huge, unmanageable collections of data can be made accessible and manageable through the clever trick of alphabetic sorting. encyclopedias, lexicon, dictionaries, but also libraries, catalogs, concordances, and keyword indexes make knowledge traceable through alphabetic sorting. The global triumph of the alphabet is also rooted in its role as an organizing matrix. The flagship of epistemic modernity, Diderot and d'Alembert's Encyclopédie ou Dictionnaire raisonné des sciences, des arts et des métiers, did not organize text narratively, but in a non-hierarchical alphabetic ordering. A huge corpus of text-image relations presented in more than, or not in more, but in precise 35 volumes, which could not be surveyed by any individual, gave individuals direct access to the collective knowledge of that time. The first European encyclopedia, as all alphabetically sorted documents, embody databases avant la lettre. Let us now look at the Indo-Arabic numeral system. Al-Khwarizmi, a Persian scholar, introduced the Europeans to the decimal position system invented by Indian mathematics. While the Roman numerals that were once common in Europe required an additional calculating instrument, the abacus or calculating board, Al-Khwarizmi taught purely written arithmetic without further technical instrument. Cognitively complex arithmetical tasks now became solvable as a process of rule-based sign manipulation. These rules are called algorithms in the wake of the Latinization of Al-Khwarizmi's proper name. Algorithms enable mental work to be carried out in a non-mental, so to say, mindless way, independent of the presence of a consciousness. The operativity of written computation lies in the fact that no reference is made to the meaning that is the semantics of the characters during the act of character manipulation. Thus, the sign for 0, for example, can be operated efficiently long before George Boole was able to give a consistent set-oriented interpretation of 0 as the empty set. An anecdote about the mathematician Carl Friedrich Gauss as a 9-year-old schoolboy illustrates written arithmetic's potential of operationalizing cognitive processes into character transformations on paper. A teacher gives the pupils the task of adding up the first 100 numbers. The pupils calculate, usually with the wrong result. 9-year-old Carl Friedrich Gauss, however, finds the correct solution in a matter of minutes, 5,050. How did he do that? Gauss did not perform a complex mental operation, but used the spatial properties of inscriptions. And spatiality matters here by positioning, grouping, and regrouping signs on paper. He altered the chronological order through transposition and brackets. Look at line 2, combining the first and the last, the second and the second last. An optical situation arises by this sign manipulation. Look at line 3, as it becomes obvious that the sum of the numbers in each set of the bracket is the same, namely 101. Now it's only necessary to multiply 100 by 50, and you get the solution. Written arithmetic in the decimal position system is an example, and only an example, of a symbolic machine. Complex forms of thought are operationalized as mechanical symbol manipulation. Before the invention of the computer, we invented the computer within ourselves, so to say, in the interplay of eye, hand, paper, pencil, and sign system. Alfred North Whitehead remarked, civilization advances by extending the number of important operations that can be performed without thinking about them. There is a particular feature with alphanumeric practices that is so obvious that it is hardly been noticed so far. It is always about inscribed surfaces. I call this phenomenon artificial flatness. Artificial because empirically there is no flat surface. The plane is a mathematical concept, so to say a non-empirical concept. But we handle inscribed and illustrated surfaces as if their depth is annulated. Why is the reductive cultural technique of flattening so productive? We live in a three-dimensional world, but we are surrounded by illustrated and inscribed surfaces. Skin tattoos and cave paintings, the invention of pictures, writing diagrams and maps, to computer screens and smartphones mark a cultural technique of flattening that forms a thread of human cultural history. All sciences, many arts, complex technologies and architecture require diagrammatic representation as a medium for experimentation and design, for communication and instruction. The bureaucratic organization of modern societies is hardly conceivable without personal documents, forms and files, credit cards, display boards, tickets of all kinds. Everything that is, what is not yet, and what can never be, can be projected onto the two-dimensional surface. This also includes the so-called impossible objects. The illustrated and inscribed paper becomes a laboratory for thoughts, a playing field for composition, or an experimental space for construction. But what is the artifice of the cultural productivity of artificial flatness? I want to explain this secret of creativity by reduction with two arguments. First, everything that is physical can be characterized by three perpendicular axes: right, left, up, down, and front, back. What lies behind us without a rear view mirror is neither visible nor controllable. The invention, and this is the first argument, the invention of artificial flatness creates a special space of two-dimensionality that opens up a complete, so to say, nearly complete overview, manipulability, mobility, social sharing, and above all, manual control. And the second argument is, there is a further aspect referring to two-dimensionality as a medium. From a live world perspective and independent of mathematical complexity, time is one-dimensional, but our bodily space is three-dimensional. Two-dimensionality forms something in between, located in the middle, that functions as a medium for transfiguring time into space and vice versa. In this way, speech can become a text, and the written text can be performed orally. Music scores and choreographies become stage performances, and computer programs transform into complex executed processes. Of course, this time-space transformation is not a simple act of translation or mapping. It is a metamorphosis in which the temporalized or spatialized mode of being changes fundamentally. Dance becomes ballet through choreography. Music can take on the complexity of a string quartet or a symphony. Alphabetic writing opens up new ways of dealing with language. The crossword puzzle demonstrates radically what is evident in the notational iconicity of any printed text. There are headings, footnotes, tables of contents, paragraph punctuation, and white spaces. All phenomena that have no equivalent in oral communication. How is artificial flatness connected with digitality? I want to present some examples. There is a close relationship between computers and writing. J.F. Bolter has systematically analyzed this connection. The concept of notational iconicity illustrates the extent to which the alphabetic script draws on artificial flatness. It is not a great step to show that the computer-based form of the digital is also strongly entangled with the cultural technique of flattening. I want to demonstrate this with a few historical examples. Just a few spotlights on pioneers in connecting artificial flatness and digitality may be mentioned here. Gottfried Wilhelm Leibniz, the philosopher, Ada Lovelace, constructing the first computer program, the first running computer program, and Josephine Miles, so to say, the mother of the digital humanities, in my view. The philosopher Leibniz anticipated the structure of the digital in many respects. He invented binary coding. Here you see his manuscript with the dual numbers. The first 4-species calculating machine and an alphabetically coding machine. This is all well known. But less well known are two other areas in which Leibniz did pioneering work. It is the productivity of the net and the networking and the folding of surfaces. In antiquity, the net was seen as a trap, a deadly obstructive or a deadly obstruction to mobility. Leibniz, however, conceptualized the net and the network in an alternative, so to say, constructive way. The net was his answer to a foundational question: how to organize a set of individuals as an interactive team and community. He constantly worked on establishing networking in science, following the model of the French and English academic societies. He founded the Brandenburg Society of Sciences and Humanities and became its first president. The cross-linked form of the encyclopedia also preoccupied him, not only as a handbook to represent a net of interconnected knowledge, but also as an epistemic tool for producing new knowledge by discovering previously uncovered epistemic connections between pieces of knowledge or text. Even in his practical suggestion for setting up water and wind circuits in German mining industry, he sketches the net-like self-organization between different components and forces in mining. He invented vertical windmills on paper to organize water pumping in mining. To optimize mining, he proposed table-based data collections that combine meteorological observations with local topography, water and wood reserves to anticipate how mining's productivity could be increased by collecting and inscribing data with tables, graphs, and diagrams. And yet he was hopelessly ahead of his time with these ideas. Perhaps the most fascinating idea of interconnectedness characterizes Leibniz's philosophy and metaphysics. For Leibniz, everything that exists is individual. But given this fundamental individuality of all substances, Leibniz calls them monads, how can their community and interactivity be guaranteed? Leibniz's answer is to conceptualize the monads as a net-like composite. All monads form nodes in a network. Their connection is not a causal but an informational one. Each monad represents the totality of all other monads from its individual point of view in the form of internal convolutions. In this phenomenon of convolution, a hitherto unseen analogy emerges between contemporary models of deep learning, the cultural technique of flattening, and Leibniz's conceptions. The folding or convolution was a central subject for Leibniz and the whole Baroque time, as we know. Folding makes it possible to create more surface area with less space. Some monads, which have consciousness and reasoning for Leibniz, unfold their inner foldings. For Leibniz, scientific thinking is a process of unfolding. In German, we recognize also that something like thinking or recognizing or having an insight is to unfold, zu entfalten, as we say. However, folds reappear in the architecture of the hidden layers of convolutional, that is folded, neural networks. Hundreds of diagrams, and this is only one example, visualize artificial deep learning's internal structure, showing hidden layers as surfaces stacked one behind the other. Hidden layers are multiplied surfaces. To summarize all this, and it's a very short story, Leibniz constantly tried to model interaction as a network connection, diagrammatically represented in surfaces, folded or unfolded. And so to say, the perceptibility of the net is not the net itself, but the diagram of the net. Now to my second example, that is Ada Lovelace. The computer as a universal machine was first designed as a sketch, only drawn on paper, by Charles Babbage. Ada Lovelace, the daughter of the poet Lord Byron, worked with Charles Babbage and designed an executable program for his paper machine. She used programming methods that are still used today, such as conditional branching, returns, and loops. She wrote and published her program in tabular form. It was related to the calculation of Bernoulli numbers. This is her program in the original version. The horizontal lines note the stages of the individual machine parts. The columns note the changes over time of each of these components. Lovelace realized, and in this she followed Leibniz, that the machine does not work with numbers, but with signs. Her idea is that the reference of signs goes beyond the field of mathematics. Thus, the computer can, in principle, perform symbolic operations interpreted differently, such as making art or composing music. Lovelace's table is the birth document or certificate of the difference between hardware and software, between physically real and symbolically virtual machines. For Lovelace, the computer program written down on paper is an interface that connects mind and matter. She's the pioneer, so to say, of software engineering. And now I come to another woman, that's Josephine Miles. She's the first American lifetime professor in Berkeley, at Berkeley University. She transformed the poet John Dryden's work into an electronically searchable database with the help of 240,000 handcrafted index cards organized in 64 physical boxes. The IBM Computer Laboratory transformed that into a searchable electronic database. But this concordance project is only her first step. She became a forerunner of the digital humanities through the general introduction of quantifying methods in her, so to say, everyday or literary research. She analyzes word relations by looking at the complete, not only the selected, at the complete and not only canonically restricted works of her authors. She practiced distant reading before this term became common with Franco Moretti. In her bird's eye view of reading all of an author's writings, her empirical analysis of word relations lead to very new insights. This enables her to correct and revise important theorems in her discipline, for example, about the authors William Wordsworth and William Blake. She presented her results by tables and had difficulties, as you can imagine, in finding publishers to print these text formats. It is time to rescue Josephine Miles from oblivion. Until now, she has been overshadowed by the Italian priest Roberto Busa, who is generally regarded as the father of the digital humanities. But the digital humanities also have a mother in her. Our examples not only show the connection between digitality and artificial flatness, they also reveal the diagrammaticity of the digital. The epistemic use of diagrams in the history of science consists of utilizing the relations of two-dimensionality to visualize invisible conceptual connections on the paper's surface and to process them operationally. This diagrammatic nature applies to sequential symbol of alphanumeric scripts as well as to the schematic drawings. Adrian Mackenzie has demonstrated this, so to say, diagrammatic nature of the digital embodied in contemporary learning algorithms and the usual practices of computer science. We cannot go into this in depth here. Let us now ask our next question. What is data anyway? Datification is at the core, so to say, of the contemporary digitalization. By transforming texts, images, and music into data corpora, and in turn transforming these data into points or set of points, data populations can be statistically analyzed and projected. And the point matters here, the diagrammatic of the point, so to say. A simple commentary on contemporary criticism is that the traditional function of science in modernity has now been substituted by data. Science substituted by data. It is not longer reading and interpreting science, but searching for data that becomes the basic process of acquiring knowledge. However, this rhetoric of replacement is misguided. Data does not replace science and interpretation, but rather operationalizes them. What does the operationalizability of data mean? And what are data? This can only be explained using the tradition. This can already, not only now, already be explained using the traditional letter date. The string of characters 04, 11, 20, 24 can only be recognized as referring to a specific day because this sequence of digits is embedded in our semiotic calendrical practices. Within the calendar system, it is possible to operate this date schematically. It can be subdivided into hours, minutes, seconds, or extended to years, decades, centuries. Days can be automatically calculated backwards, on which week day was I born, or extrapolated into the future, on which day of the week is my next birthday. The crucial point here is that everything that is given as data can in principle be mechanically processed, and that can be executed by machines. But for humans, data became accessible and interpretable in the context of their symbolic practices only. Data are not found but created. Within this horizon of data-driven symbolic practices, we find an interesting subset of data. Our symbolic practices instantiate patterns we don't normally perceive or know anything about it. Computers are like microscopes and telescopes in the data universe, bringing to the surface what is undercover, including the cultural unconscious that underlies our symbolic activities, insofar as these activities are digitized. Computers discover and process patterns in vast collections of data that escape human eyes and consciousness. But bringing the hidden to the obvious not only matters analytically, but synthetically. The contemporary synthetic media generating text, pictures, and even videos instructed by natural language prompts only. The ongoing artificial intelligence based on deep learning demonstrates the generative and creative, and not only forensic, diagnostic nature of digitalized computation. I come to my next and my last question. Do chatbots understand what they produce? We all know that artificial intelligence, particularly chatbots that work with large language models, demonstrate astonishing text-producing performance in communicative interaction with humans. Chatbots, as we all know, are trained using billions of files insofar as these documents are part of the collective, mostly Anglo-Saxon digital social memory. The written character of the data set in training matters, in my perspective. Data corpora are broken down into tokens, meaningless small groups of letters and empty spaces. The algorithms are trained to detect and analyze statistical regularities between these tokens and predict the most plausible word sequences by using token statistics. I think this all is well known. This is the mathematical basis for the chatbot's synthetic power responding to human prompts, with mostly, not always, surprisingly sophisticated text. Let's be clear about this machine modality of operation. When people use language, they do so normally oriented to meaning. It is more or less sense, significance, and interpretation that regulate our language use, or regular language use. However, every written language represents a mathematical statistical regularity between its inscribed letters. When we write and read, we have no awareness of the statistic of letter combinations. But these relations exist and are present within our text, analyzed as a computable structure. The mathematician Andrei Markov in 1913 first analyzed letter sequences in Russian literature. Previously, the statistical principles of written language were only relevant to cryptology. Alan Turing was able to decode the wireless messages of the German Navy this way. Messages originally encrypted by the Germans with the famous Enigma coding machine. Turing's knowledge of the statistical nature of written language contributed to the victory over fascist Germany. We see that in everyday life, humans and machines deal with texts in completely different ways. Language interpretation is the level and the specificity of human language use. Letter statistics is the operational level of the machine's access to the universe of the written science. If it is possible to search huge collections of text that never can be reviewed and handled by humans, and to extrapolate them statistically to predictive and not only problem-solving algorithms and large language models, surprising results emerge, precisely because the machine, compared to humans, is of a constitutive alterity. It is not human intelligence and human understanding that are performed, but computational statistics and technical token operativity that provide the chatbot's services. Token operativity is an alien phenomenon within human language use. The alterity of humans and machines is essential. So-called artificial intelligence is a kind of alternative intelligence. Learning how to interact with this unfamiliar form of symbolic production, this only statistical form of doing symbolism, will shape our future. Here, I'm at the end.
Thank you very much. One second. Wait.
we have time to discuss
Yes.
if you want to
Sorry.
have it.
It was hard to switch between the pictures. Yeah, thank you very much. This was excellent. Lots of stuff to discuss from the beginning, I guess. And so there's typically we operate with hands raised, and if there's no hands raised, I will start. So I can. So yeah, thank you very much for giving this sort of like cavalcade overview. There's certainly what you said, provocative messages in there. And as far as they stuck with me, there's two which are sort of like particularly in front and center, which I think would be very interesting to discuss. One is the idea of flattening, that there is a kind of two-dimensionality that we encounter in coding processes, such as writing texts on surfaces, writing diagrams on surfaces, and even you mentioned the neurons in these pictures of convolutional neural networks. They're typically shown as slices, which, if they're images, are also two-dimensional arrays in some sense. And then the second point is, I think, quite interesting, which is like sort of the question of the roots of what does this all go back to. And this has to do with Leibniz. And I think there is a really interesting discussion one could have regarding what was his conception of network? Is it the same as when he talks monads? Does he have the same conception that we have? And how far does your two-dimensionality carry? I think that would be sort of like two really interesting aspects. And I see there's a hand up, so maybe there's other aspects. So let's maybe first collect the aspects and then like start the discussion. So Mila.
Yeah, thank you. Super interesting. And I kind of like, as a cultural historian working computationally, I kind of like, I feel that I encounter this both problem and the kind of like all this kind of like what you call flattening also opens up for studying culture and studying history. So I kind of like and I really like your term of flattening here, and it's really interesting. I also enjoyed in a way, because you started not with like only like computers, but also with the text and how we actually need how we have been using text and numbers for centuries in order to understand the world, and in a ways that flattening in a way is one of the bases of studying the world. So we can't just kind of like get it as it is, but we need some kind of like flattening in order to grasp it. And because like digital humanities, for instance, is often criticized for using too much flattening. So I think this is kind of like interesting and refreshing approach. I really like it and really appreciate. I actually wanted to ask you, or just kind of like enter my question to this discussion, because there I kind of like see the importance and power of this flattening for studying culture. But do you see any ways of kind of like, in a way, deflattening or re-enriching after we kind of like flatten phenomenon into data, study it, and how do you see, is there a way of kind of like relearning some, or kind of like re-enriching or unflattening it? Yeah, thanks. Super interesting.
Shall I answer, because with time
maybe
too much I cannot have.
Yeah, I will come back to what I mentioned. I just wanted to frame the discussion as like the scope of the discussion. But why don't you start with Mila's question?
Okay. Well, we all are socialized in a rhetoric of that good thinking, fruitful thinking is deep. you have to go to the groundation, to the foundation, and so on and so on. You all know this story. And I was always surprised. Why are we so very blind with regard to the phenomena that the history of science and parts of the history of the arts is founded in using techniques of two-dimensionality to organize something? And having this perspective, for me, I discovered that nearly all our cultural phenomena are depending in one manner or another on this phenomenon of flattening. I know we are three-dimensional. Our corporal reality, we have three axes, a perpendicular axis, and not four or not two or whatever. But the interesting thing is the interaction between, the connection between flatness and, so to say, or n-dimensionality in a mathematical perspective. But to get to the point of the interaction between flatness and non-flatness is in the first step to understand what does it mean, this flattening out. And because as a philosopher, I want to enlighten, so to say, about a phenomenon in culture, what we constantly lacked when we tell people to be deep and not to be superficial. During we all are reading text, we all are going to the surface of the screen, we all are manipulating our smartphones and so on. There is something wrong in this view, and therefore I take the idea of reflecting about flatness for a lot of years. It was my topic, so to say. But flattening, this is really a very this is very relevant topic, because the very interesting thing, I have completely let it outside, is that time is introduced into the electronic networked surfaces. And what is happening when time is introduced in the screen, so to say, in writing, to the writing transforming into a link, for example, QR code or whatever. And one of the most interesting phenomena is that by the engineers in computer science, the introduction of time into the two dimensions of the programming languages and so on is called the third dimension. You mentioned it is three-dimensionality in computer science, but the first dimensions are the columns and the lines in normal informatics, in the diagrams of the learning machines. And the third is time functioning as the third dimension. And this, I cannot speak a lot about it. Google, I think in 17 has invented a new storage device, because you know, in the search engines always have an overview what kind of pages have been transformed in the last second and what kind of pages have been the same. This was a big problem for all the search machines. And to solve this problem, there was invented a specific time techniques. Google table, I think it was called a table technique.
Big table, yeah.
Yes, and for example, we have to look for this kind, to reconstruct that now time is going on to be the third dimension in informatics, not in our real world. No? In our real world, we have three spatial dimensions. And only one last comment. In philosophy, it is always normal to tell you that time is the most relevant dimension in human life. We all know that, yes, we are born, we have to die, and so on and so on. And my students and even my professorial colleagues are always getting younger and younger. That's my experience of time. And well, Heidegger has told us, has built a whole philosophy around this idea that time is in the center of what is philosophically interesting in our human existence. But I think whenever we are disoriented, whenever we have a problem, we don't know what to do, then we are going back to spatial relations to get clearness, to get knowledge, to solve a problem. And therefore, I think time is the existential, so to say, of human life, but space and spatiality is the most relevant epistemic tool, yes, for doing research, for orienting, and even for operating data. Oh, a long answer, and yes, this would be my answer to Mila.
Okay, so thank you very much. I try to, like, I'm a fellow Leibnizian, so I'm deeply fascinated by Leibniz. And I try to be at the same time, what I will say is at the same time a panegyricus of what you're saying, because I think you're very much up to something. And at the same time, I want to play devil's advocate, because there is a number of things which I think this two-dimensionality does not lend itself to. One thing is that Leibniz saw himself as a diagrammatic thinker. Ada Lovelace obviously was, because otherwise she wouldn't have written these tables. That's exactly what he emphasized in Miles. And that's something that we can see in multidisciplinary science, we can see in network science or cultural data analytics, digital humanities. We draw these kind of pictures. Typically, we do that on 2D surfaces, indeed. I did my PhD on Renaissance drawings, so I'm very much with you that two-dimensional surfaces have been the loci of recording and externalizing cognition in ways that precede language, while at the same time, there are certain things which I don't buy. Like, for example, whales certainly have a language, and they're very clearly writing does not precede the language. Definitely not. Like, there's no medium to write, there's no surface, they just sing to each other, and there's meaning, increasingly recognized so. Now, there's this other thing which you gave yourself the key to, which is, you said Ada Lovelace realized that she's not actually just dealing with numbers, but she's dealing with signs or symbols. And that is a really interesting thing, because Leibniz understood this also very, very well. Like in his sort of introduction to where he introduces calculus, he says as a side note that the actual foundation of math is just relationships, and it's qualitative, not quantitative. He actually also makes this point in his sort of metaphysics that space and time come later, like sort of extend what he does not say space. How space is set up, constituted by relationships, by the compresence of things, and extension comes later. So the measured dimension we have in our three-dimensional space and the measured dimension of time comes later. So space is constituted just by the relationships. And now here's a very interesting thing, because this has been deeply influential, not only both for cultural history, but also for math, for topology, for computation, and for physics. And there comes in a thing that is deeply disconcerting to this notion of two-dimensionality as an imaginary space, which is that all these things, computation is multidimensional, physics is now, particularly as influenced by Leibniz, multidimensional. So there's this piece where Norbert Wiener writes, back to Leibniz, physics is occupying an abandoned position, where he actually makes this point that quantum physics, particularly, is multidimensional. And so, we have Hilbert spaces, and there is this idea that monads sort of like fit really well with this. Like, if the whole world is contained in a monad, then obviously the world must be multidimensional, because there is monads, and monads have imaginations of other monads and so on. And so it cannot be just 3 dimensions, because there is not only the actual space, but also the imaginations about what the space could be and stuff like that. And that repeats itself in computer science, where you find, like, for example, the topology of a graphical processing unit, of a GPU on which you run neural network, is typically minimally a 12-dimensional hypercube. Probably now more physically, which can be done with wires. And obviously, you know, this is in 3 dimensions, but the topology of it is higher dimensional. And what is represented on it is even more higher dimensional. And I think that is sort of something which I think is a quite interesting thing, because again, you sort of delivered the key. When Ada Lovelace says, it's not numbers, it's symbols in general, and can be anything. Why do you think the symbol needs to be 2-dimensional? Like in the convolutional neural network, an array that is in a neuron can be multidimensional. And the shape of the neural network itself can be multidimensional. And that is, I think, one major issue, that we have these realities in computation, in mathematics, in physics, while in the digital humanities and in the humanities, we do not acknowledge that. We are still stuck in our semiotic thinking of 2-dimensional writing systems, of text, of diagrams, and representations, which do not acknowledge that what's happening in the computers physically, what's happening mathematically in the structure of how we write out stuff, is actually way beyond 2 dimensions. And I have just as a hard time imagining that as anybody, I guess. And that's sort of like what we try to wrap our head around. So the question is, do you think we can redefine this idea of flattening? Like, there is obviously something going on, which, this may be the last point I'm saying, which I think is a bridge, is like the information theory tries to describe systems in shorter length than the system itself. This is something that must be true for monads. So we are, if every one of us is a monad, we all have an imagination of the world, which must by definition be smaller than the world itself. So the description length of the world in our head is shorter than the actual real world. So in physics, this is a notion of understanding, right? You said you have a formula which is shorter than the real world, but gives you enough information about the world so you can actually operate in the world. So this notion of description length is, I think, deeply resonant with what you're saying about flattening, right? So basically, every flattened 2D surface that is a diagram is in some sense something that has a shorter description length than the actual thing it depicts. And there, I think one can actually take your paradigm, which I really like, and sort of extend it beyond this 2D notion. But this will not be simple. I think there is something where whoever does this will walk out of the room, and there won't be digital humanists, there won't be computer scientists, they're minimally both, and they're probably much more than that. And that would be really, really exciting. So the question is, where can we do that? Because what you just said may be criticized in multidisciplinary science. What I just said is very well criticized in the digital humanities. So how do we create common ground? I'm not quite sure, and I'm still struggling, like seriously struggling in the real world of how to do that. Like, where can this be done? We're in this amazing situation where we can do this for 4 years, but you know, it's 4 years, and so that is sort of like a difficult thing. That was provocative. Sorry.
No, if there is really a question I'm able to answer, because it would be a complete mistake to think that we only have 2-dimensional symbols. No, never. Think about art, think about dance, think about the whole world. There is, normally there is 3-dimensional, 3-dimensionality. And the question is, what's about the relation between our corporate 3-dimensionality and the rest? Conceptualizing as Möbius band, that is 0-dimensionality or 1-dimensionality or n-dimensionality, and the 2-dimensional. And I think that's sure that in mathematics, in science, we are imagine a lot of dimensions. You all know that you cannot do the construed deep learning algorithms without going a multi-dimensional, so to say, a coordinate system, not only the Cartesian two-dimensional coordinate system, but you have to construe very complicated system. I know that, but this is not the point. What I'm asking me is there any privilege for the Euclidean point of view for this kind of 3 and 2 dimensionality in relation to the fantasy of having 0 or a lot of more dimensions? And therefore, I think that it is our embodiment in the world that forces us that if we want to get clear about a complicated situation, we have to illustrate or inscribe the relations of this complex, more dimensional situation in terms of 2-dimensional symbolism. And this is only my point, so to say. I do not want to neglect, this would be silly, completely silly, all the more dimensional activities. But I want to show that first the blindness, the continuous blindness with regard to that 2-dimensionality in philosophy. Nobody thinks that having diagrams is of any relevance for thinking, for example. It's only illustrating what you have inside your head. But it was Wittgenstein to tell us, no, thinking is not situated in the head, but it is situated in the paper. You are writing something down, and it is situated in your voice, giving acoustic signals. And therefore, these very, so to say, anthropological questions are connected with this idea of 2-dimensionality. But the most relevant thing is, no, never. Symbolism is more dimensional, and even reality. That's yes.
So what you just like, I wanted to give the word ahead, but like what you just said, I think is please explain. So you said nobody until Wittgenstein was thinking that, you know, the thinking is going on in the brain, and nobody, like, diagrams are just illustration. So this clearly, and like, let me cite an anecdote to tell the audience how real this is. I had a master student who was bachelor in English literature, master student in art history, but she also learned to code and to do visualizations. And she did a project where she visualized data. And the person responsible for the curriculum in her school told her, in my presence, drawing figures is just creative, not analytic. And which was exactly this notion that supposedly diagrams are just illustration of thought and not actual process of thought. So this does exist, while at the same time, this is totally not true, since also a very, 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 very long time, there is, like Leibniz, drawing thinkers. They exist since antiquity, even in the Uruk sort of like clay tablets where they didn't even have the numbers yet, they already drew pictures that symbolize something quantitative. So that is a sort of like really difficult thing, I think. So is there is there this notion of 2-dimensionality, or do we have to see that actually multidimensional thinking makes use of lower dimensional tools, such as the 1-dimensional practice of spoken language, such as the sort of 1-dimensional act of written text, and 2-dimensional drawings? Or is it that humans are fundamentally aware since a much longer time that thinking is also multidimensional, maybe not explicitly, but at least in practice? Because there is a lot of like this kind of like cognitive science rolling out, like Gerdon force and so on, where we actually do surmise that there is a multidimensional kind of like cognition going on. And ironically, this has been ignored wildly in the humanities in the last 70 years. more or less. I don't know. I don't know why, but like this is something that is a really crazy notion. So the question is it really the case that this two-dimensionality is sort of governed and governs our thinking? Or is it so that we just have a hard time depicting the actual multidimensional thought process, while people are typically aware of that the thought process is multidimensional?
First of all, it is not Wittgenstein the first to think about that. I've written, sorry, it's in German, not yet translated, a book on diagrammatics in philosophical reasoning. It begins with Plato. He has diagrammatics. He has the simile of the divided line. Plato developed a lot of procedures in two-dimensionality. No, never a lot of thinking in terms of two-dimensionality through the whole history of philosophical work. That's clear. And therefore, yeah, I do not really understand what is at stake at the moment. My aim is to show that there is a specific connection between the cultural techniques of writing on the one side, the cultural techniques of flattening as a very general anthropotechnological cultural technique. And even the term of cultural technique is very relevant for me. It's, so to say, a new term. We created it in the Berlin School for Helmholtz Zentrum for Cultural Technique to give another picture of what it is to have culture, a non-elite, so to say, picture. This would be a very relevant question to what is cultural technique in general. Yes, but my aim was only to show that there is something we normally don't look at, and that we have to comprehend the connection between digitality is story. We all know that to manage the large language systems is, I hope it works. Okay.
Yeah, we had a 3-second gap, but you can.
Only two-dimensionality, but that the files used for training for the generative media is written down, is token-oriented, and that a token is a two-dimensional form of written signs and empty spaces, a small one without meaning. These are the phenomena I'm reflecting on. And you are completely right that the world and even physics and complex thinking is more than two-dimensional. Thinking is, I do not know, but it's not two-dimensionality, the frame of thinking, but it's a tool. And I want to get clear about the secret, why it is so productive. Look at you behind. I always see the pictures, writing everywhere, screens everywhere. I'm looking for the answer. And I think one answer is that two-dimensionality is situated in between as a medium, in between the one-dimensionality of time. It's a little bit complicated with the one-dimensionality, but yes, and the three-dimensionality of our world. And therefore, this would be one answer, that we can transfigure space to time and time to space. And only, yes, this is what I can offer you. Perhaps I cannot answer the questions you are giving to me.
I have a follow-up question in my head, but I'm not allowed to. Michael Thomas, the next person. He's already annoyed.
I probably have sort of questions, but first of all, I have a sort of a series of comments about this dimensionality story. More partly from the physicist point of view, given that I want. Basically, one thing I wanted to stress is that we are, of course, not living in a three-dimensional space, we are living in a four-dimensional space. That since at least onset of the relativity theory, we do know that space and time are indeed interchangeable dimensions. So although we experience them as humans differently, it is indeed a single sort of complex of dimensions. Second thing I wanted to point out that there is sort of an elephant in the room here, which is basically that our eye is trained to render and recognize and process two-dimensional images. Yes, and it is in the end of the day, behind it, there is the simple fact that what dictionary tells me is called ocular fundus. Yes, the surface of the inner eye, which is the set of receptors which perceive the light and perceive the images which we further process in our brain. It is two-dimensional. And that, I think, is very large part of why processing two-dimensional objects for us is much simpler than processing three-dimensional objects or four-dimensional objects, like dance, for example. Dance is, by the way, as far as it is sort of a set of symbols, is a very good example of why it is actually four-dimensional. Yes, it is not a matter of position in space, fixed position in space, how it changes in time. It's 4 dimensions in it. And one that is a sort of a second comment, and the third comment was, I think it is probably somewhat esoteric, but I think given that you ask this series of questions, I think it is to some extent, well, at least curious that there is a huge business in theoretical physics in the last decades related sort of to two-dimensional physics. And it turns out that there is that it is not just that two-dimensional systems are simpler than three-dimensional. They have qualitatively similar phenomena, but simpler and easier to grasp with your mind. But apparently, there is something special about two dimensions in a sense that there are lots and lots of models which are exactly solvable, which you can mathematically track exactly, whereas in three-dimensional you can only sort of guess, extrapolate, construct some sort of approximate theories, etc. In 2D, you have conformal field theory. You have models like Ising model are exactly solvable. You have Schramm-Loebner evolution, where there is series and series of things which are exact in 2 dimensions, which in the end of the day goes back to the fact which is different from what we have discussed already, which is that you can construct a 2-dimensional number system which has normal arithmetic operations, which is not true about 3 dimensions. You cannot do it in 3 dimensions. You can do complex numbers which are 2-dimensional number system which doesn't have order but has all the rest of what we used to have in numbers. Well, that is a set of comments I had, and I actually have a couple of questions. One is actually about something you just told, and I haven't understood why you say that tokens for large language models are 2-dimensional. And the second question is, am I right to understand that you say that humans and large language models are sort of qualitatively different in how they process the language data, and why do you think so, if yes?
Can you perhaps, Mike, I couldn't understand the three questions at last, please.
Yeah. So my questions are these. There are two questions. Number one,
Okay.
you said that tokens in large language models are two-dimensional at some point, just 5 minutes ago, and I was surprised to hear that, and I want to understand what you meant. And the second question is, am I right to understand that you say that humans and AI process language in qualitatively different ways? And if yes, then why you think so?
Okay, thank you, Mike, for the question. No, what I have told you is only, well, reflecting on the function of spatiality in our epistemic realms is reflecting about the role of points and lines. Writing normally is on lines, we use points, and so on and so on. Well, and points are a very relevant form of representing. Point is zero-dimensional in mathematics, you know that. But the point is a very relevant representational form to present data and to process and to operate data. And this, for me, is a very interesting view how to explain how the machine works in identifying or clustering or whatever. For example, if a machine has to differentiate between cat and dog pictures, it is like calculating a function where you can separate the points standing for dogs and the points standing for cats are sorted not in neighborhood, but in a difference, in a distance. Neighborhood and distance, spatial terms are relevant in doing clustering and so on in the digital humanities. And therefore, okay, but you're back to large language models. The models, I only told you that token is only a series, a short series of written signs and empty or an empty space in between or in the end or in the beginning. And only the token foundationalism of the training of the large language models has a specific orientation to the two-dimensionality. Only this, that normally the machine is operating on a level which cannot be compared to the level of interpretation. I like to reflect on symbolism without interpretation. I'm always fascinated not by doing sense and meaning, but by not doing sense and meaning. And I want to hint that a lot of our cultural productivity is founded in a kind of handling symbols that is not guided by interpretation and meaning. And therefore, I want to show that the very surprising results and even the hallucinations of the chatbots can be going back, or you can go back to the very symbol it's not a symbol, but the huge data corpora in form of token operativity. That is the basis and not the interpretation of the words. And this is my point. You can reduce semantics to token operativity. And therefore, I want to hint that normally, I'm coming from the philosophical background, philosophers are fascinated by the idea, can a machine think? And I think we have to differentiate that whatever a machine is doing, even if the result is analogous to the human result, so to say, the machine is doing on a completely different level. And this level is not guided in the normal sense of having mean and interpretation, but as I think on calculating statistical relations.
So that
Yeah.
would be.
I don't understand why. I frankly don't understand why we do not know how the human mind operates. We know our subjective feelings about operation, and if we go into the sort of to as much as we know of the neurology of how it actually happens in terms of levels in terms of transmitted electric signals, etc. It seems quite similar to what computers are doing, although to what neural networks are doing in large language models, and the results are looking very similar. How ChatGPT answers questions is very similar to how sort of lousy bachelor student which is trying to gaslight you is communicating with you. It is actually quite similar, and I'm not yet sure that it is not exactly the same underlying process inside.
Yes, as you told us, we really don't know what is really happening when humans are thinking. We know it's a long way to get clear about that. But my point would be that it is not to imitate that, so say, the logic of the machine is not only to imitate. We know, going from the traditional artificial symbol process operating to connectionism and to neural networks is already a step in the direction of the human biology. But I think it's only a very small step, and it's only a thesis. My thesis would be that not the imitation of human acting, whatever kind of acting, by hands or by brain or whatever, is the way to get this kind of machine productivity, that the machine is doing its duty, its service in a completely other manner, even if the result, I repeat it, is nearly.
But is this a desire we have as humans? It reminds me a little bit like there's this book on Jesus of Nazareth by Josef Cardinal Ratzinger, who sort of like masterfully describes how Christ sort of like fulfills all the hallmarks and all the properties of a princely religion in Hellenism, but then nevertheless states that he's different because he's Jesus. And so that is sort of like we would like that to be the case, right? Like I'm with you. There is a huge difference in a sense. You know, obviously we use 60 watts and a schnitzel semmel at lunch, plus a little bit of water to do our thinking and our interpretation, while, you know, Google and Facebook sort of like burn the equivalent of the Hoover Dam of electricity all the time for doing something that smells rather similar. But that may be just bad construction, but that does not mean that the process is not the same, or maybe that is different but on par. And so let me get to back to this roots thing, which I think is a quite interesting one. So the Helmholtz Center for Culture Technology, for Kulturtechnik, was co-founded by my PhD advisor, Horst Bredekamp. And Helmholtz is obviously a sort of intellectual hero in the city of Berlin, because he was located there. He got a lot of funding there. He did a lot of really groundbreaking stuff on the sensation of tone, on optics, on cognition, and so on. And the more wild stuff, which drove me to Tallinn, is the kind of stuff where he had to get funding from Baden-Württemberg and Bavaria, which in his tonal sensation, he says on page 1. So doing the kind of more crazy stuff, he had to ask not the Prussian government. But nevertheless, so it's together with the Humboldt Forum, the Helmholtz Center for Culture Technology is sort of like also making reference to the fact that Helmholtz is sort of like a local hero, right? While one interesting thing that is quite interesting is that the Helmholtz Center for Culture Technology is different from Helmholtz. Helmholtz was also a physicist. He was also an acoustician. He was also a neuroscientist. He was also an instrument builder. He was also a humanist. And that is decidedly not the case. So we focus, and like I'm very much guilty, like by my PhD is very similar to whatever people do at the Helmholtz Center for Culture Technology. We focus on text and images, and it was sort of the struggle of our generation of researchers in Berlin doing art and cultural science kind of stuff to say, hey, images are just as valid a kind of thing to think. There was the iconic turn and Burda, and like it was a huge German tradition of doing this kind of thing. And the Helmholtz Center for Culture Technology is very much one epicenter of doing that kind of thing. But now there's one big question, and let me bring an example that Helmholtz himself raises. So we have a 12-tone system, and you can try to fit this, like, you know, where like one octave is has double the frequency. You can try to fit the semitones of the 12-tone system into sort of like the actual existing spectrum of sound, and it doesn't work out. And so people realize that. And, you know, if you don't hit the right note with a violin or something like that, people who are trained classically in the 12-tone system may say what you do is wrong. But still, you have different ways of how to sort of fit your 12 tones, well-tempered or not, into the actual spectrum of sound. So Helmholtz said, like, actually, you know, you could actually come up with another scale which has 53 divisions. 53. This is like a not very even number. And you would still be slightly off. So in fact, no matter what kind of system we come up with of notation, we cannot fit the real sort of like nature of sound, because whatever happens there's always some kind of residual. So nature does not fit our notation system. And now this is a really interesting one, because this basically means that our notations, and no matter if it's writing or if it's drawing, is sort of off. While at the same time, we're unbelievably good dealing with nature. Like our eyes, they're not two-dimensional. Like the perceptive field is anisotropic. You see less sharp on the outside than you do in the middle. And people realize that already. Helmholtz certainly realized that. Ernst Cassirer, sort of preceding Panofsky, this is like one of his core tenets, to say there must be some kind of translation from the real world, 3 dimensions, to the inside, which is multidimensional, via this sort of perceptive facial tactile sense, which is anisotropic. So it's not 2-dimensional. So there is something that's 3D, stuff we write down as a system of writing or in diagrams, and we translate it via this like really weird thing in a sort of non-isotropic way into a multidimensional imagination, which we have no clue how it works. But that's actually not true, because we live in 2024, and Wolf Singer certainly has clues about how it works. And a lot of neural network people also have some clues how it works. And that's probably one of the reasons why this stuff works so good. But we cannot fully replicate it. But the key thing is the world is way more complicated than we like to have it. Like we could, for example, write an article in the journal of the Helmholtz Center for Cultural Technology about the drawings Merce Cunningham does about dancing. But neither this article nor the drawings themselves would sort of like reproduce what happens in the head of a dancer who looks at a drawing of a dancer. Like what you see here is a sketch by a ballet dancer who was at a conference here, which sort of, when she would look at this, would not just sort of like see the form, but in her head would have a simulation about like what the body does. And not only that, which was a 4-dimensional thing, like 3D plus time, but would include sort of a multidimensional, at least partial imagination of what could happen. So she needs to avoid what could happen. And we do this all the time. Like if we ski, if we ride a bicycle and so on. And so there is this kind of thing where I think there is a huge difference where, unfortunately, what's happening in our brains is way less flat than what happens in these neural networks. And here I would like to make another point. One interesting thing where you're absolutely right is that there is a kind of almost disease going on in science and in computation, that we deal with flat systems, which is category theory, which is the basis of all the math and linear algebra that we're doing, has only pointers. There's only arrows, there are links, and therefore we have a binary view of mathematics. All the representation we do in neural networks happens with matrices or maybe tensors and so on, but we basically use linear algebra, two-dimensional mathematics, to actually solve the whole system. The same is true for physics. While mathematicians
think intrinsically two-dimensional about linear algebra.
That's true, but that's
but
the implementation.
And you are sort of casually equalizing matrices with tensors, which is equalizing two dimensions.
Let me finish my sentence. So tensors are typically decomposed into binary matrices, but mathematicians, just like he sort of like grumpy right now, mathematicians have pointed out that this is not necessarily what is the state of things. We can come up totally with a math that is multidimensional. We can come up with a three-dimensional math, with a multidimensional math, which, you know, produces new algebras, which may be way more efficient than what we use now. And that may actually be the difference. The difference between our shitty computers, like that this thing gets really warm when it does what it does, and us not getting so warm, may be that nature is already doing it, we just haven't seen it yet. So that is sort of like a key thing, is I think there is a sort of, nature is way more awesome than we imagine, and our science systems can be more awesome than we think about right now. And my question to you would now be, could it be that philosophy, semiotics, is stuck not only with text, but also with iconicity, with images being 2D? And do we just have to get beyond it? Like, do we have to all become dancers? Sorry.
What to answer? It's trivial that nature is not notation. Nature is not diagrammatics and so on and so on. And that it was already Nietzsche to tell us as a philosopher that dancing is the main activity and the model of the human being in the world. And therefore, I do not know.
Could I disagree with you on this? Like you said, like nature is not notation. Life certainly is. Like we literally do exist because nature has come up with several notation systems, with genetic code, with RNA, with protein folding, and that's a folding where, in the sense of Leibniz, the information is actually folded. That is unbelievable. It's not a network, but it's actually in the folding. And so there's this kind of thing where, like, again, like this is sort of something which, after having been with Horst Bredekam, hanging out in a physics lab with way too many systems biologists, that this awe that nature is more awesome than we can ever imagine, and there's like amazingly a lot to learn, that we cannot go back to these classics. So it's almost like all the philosophy that has happened is super awesome, but it's way too short to understand what's in front of us, because what is in front of us has inspired people like Wittgenstein, Plato, and so on, but they didn't have the instruments. They couldn't take a look. They could not calculate. They didn't have a computer. They didn't have a telescope. They didn't have a microscope. They just did not have all this kind of stuff.
I do not know. I not really understand. I think there had been big instruments. That's normal life, that instruments are evolving, that in 100 years, we cannot imagine where our instrument, we only can reflect on the instruments we have at moment. And therefore, yes, but at moment you tell me get rid of iconicity. I can tell you, coming from a textual science as philosophy, I had to introduce the idea of notational iconicity, that a text is not only a series of signs, but you have to look at that there is interpunctation and that there is some corporality of the text and so on and so on. And therefore, I cannot understand what it means to get rid of iconicity, for example, in this realm. I bring iconicity back to our conception of writing, because the alphabetic alphacentrism, the phonographic alphabet, was always looked at without iconicity. And therefore, yes, I do not really understand what is at stake at the moment. I really do not understand. Sorry.
Do you think it could extend iconicity to?
Really, in the Helmholtz-Zentrum with Horst Bredekamp, and we had Thomas Macho and Kittler, and you all know we had been seven founders of the center, and we have not only been oriented to iconicity, you know, because yes, and what is iconicity? And we have to reflect about that. In my view, I cannot understand a sentence like "get rid of the iconicity." It depends what you want to show in your science, in your realm. And my science, my philosophy is very text funded, and they do not like pictures. I had to tell them that Plato constantly used pictures. He was not an enemy of the pictorial. He was not an enemy of iconicity. I have written a big chapter on that to defend Plato from Platonism, and that he was not only oriented at text and at writing and not at pictures. He constantly used the pictorial to explain what is at stake in his philosophy, and this was interesting. And therefore, and this is with all the thinkers. It is with Descartes, it is with Kant, who was a very interesting thinker, why the Euclidean geometry, the three-dimensional geometry, also the non-Euclidean geometry, was already known by Kant. He defended the Euclidean point as the main relevant point. And for me, it was an interesting question, why? And I found that in Kant's thinking, there was a kind of corporality of going back, and I can give you citation, not at the moment, quotes to that Kant was going back to our corporal reality and told us that this is the reason why the Euclidean geometry is something like a conception, how to diagram reality, the fullness of reality into 3 dimensions. But it's not an answer to any, I told you, at the moment, I do not really know what to answer, what is the question. And I'm sorry about that, but well.
No, maybe I should clarify. I apologize. There's this key thing that I think there's sort of like really interesting tension, which is for about 70 years, there was a sort of back and forth between text and image, right? And so Richard Rorty with the linguistic turn, and then the iconic turn in the early 90s, pictorial turn, and so on. Obviously, one could use other examples, but the interesting thing is this is definitely something where both of us come out of this tradition where, you know, when I studied art history in the 1990s with the same people that you're mentioning, is we said like, oh, we need to actually also take into account the visual, the pictorial, the iconic, and so on. Now, one of the interesting things is that we were stuck in a world that talked about 3 dimensions, that talked about 2 dimensions, because art history is stuck in this. Like Panofsky sort of in Perspective as Symbolic Form leaves out the multidimensional aspect that he could have taken over from Cassirer, but he didn't. And there is to this day people in German art history who say 3-dimensional space is the basis of architecture, for example, which is from a theoretical perspective, pretty preposterous. So they pretend there is, like Schmarzow said in the late 19th century, there's nothing beyond 3D space, but that is obviously not true. And so one of the interesting things is that texts, as you mentioned, and also these two-dimensional diagrams are windows into a more multidimensional imagination. And that multidimensional imagination now comes back at us in a functional way. And so this is a really crazy notion. Like if we read closely what Warburg and Cassirer said in the 1920s, and then see what's rolling out right now with these neural networks, where image similarity can be automatically depicted, can be automatically calculated, and so multidimensional similarity can be calculated. All of a sudden, we're confronted with something that is the opposite of magic. It's not like, oh, as an art historian, I can see the iconic is important because I know that this looks similar to this, and no computer can calculate, no text can write it down. But ironically, the exact opposite is the case. It's actually written down in symbols in the computers, and it's calculated in the computers what the similarity between two pictures of cats is. And that is exactly the multidimensional imagination that we can calculate and write down and then spit out to actually bring two-dimensional pictures together. So one of the interesting things here is that all the stuff we leave out, but physics has recognized, computation has recognized, mathematics has recognized, and some weirdo people, which haven't been listened to, like Cassirer, hasn't been listened to by Panofsky, actually sort of like brought to the table and said, like, look, this is the kind of stuff we should do. And now we still deny it, but the computers we use do it all the time. And so that is sort of like where at the same time, I would say your work is amazingly important because it emphasizes this notion that diagrammatics is a very important part, flattening to two dimensions. You know, it's sort of like this externalized kind of cognition thing. But at the same time, there is this multidimensional aspect missing, which we have to fork back in. There is no such thing as, and so this is sort of the premise of like what we're doing here. Can there be such a thing as a cultural studies department that not also does computation, that not also does multidimensional mathematics? Or is this something we have to reintroduce? Because if we look closely, that's exactly what's going on. And I'm sorry for making this sort of like discussion sort of provocative, but the key thing is there is a kind of, it's really getting to the core of something that the whole discussion about dimensionality in the 20th century has surrounded about 2, 3, Marcel Duchamp, 4 dimensions. But in a sense, there is like the big question of like, oh, is there actually a limit? Can it be multidimensional? And what does it actually mean? Yeah, whatever.
Okay, first of all, at 3 o'clock Berlin time, I have to leave, therefore there will not be much time rest. 2 big questions. With theory of relativity by Einstein, the space and time have not longer be separated. As we all know, the modern conception of space and time is space-time continuum, and it's 4-dimensional. And therefore, whenever we are speaking about something, we first have to be clear in what kind of concepts and terms we are communicating. This only up to space and time. I think first we have to clear up what do I mean with space and time, because I would tell you that the philosopher Bergson has differentiated 2 modalities of time, the subjective durée and the measured, spatialized time. But I think the computer introduces a 3rd modality of time that is a real time, so to say. For the humans, there is no interval of time any longer. It happens immediately. But for the computer, there is still a time interval. This would be, for me, a very interesting question to discuss. Is that real, that after Bergson, a third modality of time is emerging, so to say, with a computerized real-time experience. But the other is the concept of diagrammaticity. For me, a text is a diagram. I'm standing, so to say, or I'm thinking with Peirce, and he has developed a concept of the diagram that includes not only the drawn diagrams, but even the sequential symbolism of a text. All this is diagrammaticity because iconicity and spatiality connect in the diagram. A diagram is not only visual, but it's a spatial tool, and therefore text is a diagrammatic, so to say, tool for me too. Well, and I can continue that word for word, we always are using our concepts in a very different way. I would never neglect that my orientation to reconstruct the cultural productivity of two-dimensional presentations is not the whole story. That is banal. Whenever you are doing research, you have to focus, to concentrate on a special question. And yes, it's not time enough to explain my special question, but therefore I think, yes, that it's, so to say, trivial, or we have not to explain that whatever I can tell you on the cultural technique of flattening out is never the whole story. And especially if you are speaking about imagination. I do not know, in German, imagination is a mental word. It's something like fantasy, doing something in your head. But imagination in the English universe, so to say, is Anschauung, what in Germany we say, look at, really to look at. And I would say that Maike is right, that our eyes perhaps are organized in the biological manner of using two dimensions. I cannot speak about that. That's not my realm. But we are sure that the word and even our conceptualizing the word is not restricted to the main function of two-dimensionality. That has never been my goal to take you with me in a two-dimensional world and to tell you that's all what matters. No, but it matters a lot. And you know, dance is not ballet, it's not choreography. We all know that. Nobody wants to reduce choreography to ballet, ballet to dance, and so on and so on. And therefore, okay, at the moment, I do not know how to continue because I have to leave the session after 2 hours. I did not know, and excuse me once more again.
No worries. Thank you very much. I think in some sense, it's also the goal to, and this is, I thank you very much for this. This, you know, in the German tradition, which is very much, I lived 10 years in the US, where this very much is not the tradition, leaving a discussion like this, where there is different points of view that are put on the table, I think we have created it's a German classic word, a Spannungsfeld, a field of tension, which hopefully is very inspiring, both for us, for all of us, but also the other thing, this is the audience that maybe watches this in the future. So in that sense, I thank you very much for all this. Okay. I do the final job I always have to do every week, which is saying what's happening next. And next week, we're going to have Matthias Röder, who is the CEO of the Karajan Foundation, who will talk about data, artificial intelligence, and music. He is, let me say this like in a leisure manner, I think partially guilty for Beethoven's 10th Symphony. And he will be here in person. So see you all next week. Thank you very much. And thank you, Sybille. This was a really very inspiring talk. Thank you.
Okay.